Thank you very much, and what a pleasure it is to be back here. Scientists in the 21st century face challenges which their predecessors never had to face. In a sense, the easy science has been done already. Science which doesn't have lots of complicated ramifications, which perhaps society is very happy that you just go on and when you've made a nice breakthrough, come and tell us, that's good, here's the check. We're past that era. We're in an era where the problems that we solve are wicked. They are both complex scientifically with a huge technical component, much of which is ambiguous. It's not clear what the answer is. There's lots of uncertainties, there's lots of contingencies, but at the same time, they are in a social context which is contested. So people don't automatically say, trust me, I'm a doctor. They're not going to accept that. You actually have to bring the whole of society along with you in making decisions about these deep, value-driven decisions. And that's why we've seen the evolution over the last 30 years or so of this form of inquiry known as the scientific assessment. Now, if I had been speaking to you when I started my career, everyone would say, what the hell is he on about? What's this thing? I don't know anyone who does that. Leading scientists these days spend a very significant fraction of their time doing what I am going to explain to you. And it's not the same thing as we always do, science outreach, technology transfer. It's a quite different animal. It's to use the modern jargon, it's transdisciplinarity, and it's where your generation of knowledge actually doesn't all come from the science. The generation of knowledge is a co-production exercise between science and society, and that requires a very different approach and a very different training and way of thinking about the problem, and that's what I'm going to be outlining to you. I'm not going to be talking much about the shale gas assessment. It's one great example of that, and we'll hear about it in detail later. I'll be telling you a little bit about the history of how this came about, some of the success stories, and in particular, what has the role of the CSIR been in this evolution of a new way of generating knowledge in service of society. So, when I say the word assessment, of course, that's an ordinary English word. And if you look it up in the dictionary, it basically says to evaluate evidence, in support of a conclusion. And that's actually not far away from it. But in this scientific sense I'm using, you can find the word assessment, sort of a century ago. But the way I'm using it really traces itself to a much more contemporary sense. And it's essentially an evaluative process looking at what is the state of knowledge, what is known, what's not known, what is speculated but not necessarily proven, and what we agree on, because then we can put that aside, and what we remain to disagree on, because that's what we need to focus then our social inquiry, our research program, and our decisions about, our value-based decisions on it. And that just really helps to clear up the decision space. So you're not fighting over stuff, in fact, fundamentally you agree on, or the evidence is clear. You retain your discussion and debate on those issues where that is required. And it has become perhaps the key element in the science policy interface in the contemporary time. Where did it come from? So the first one in this modern sense was in 1986, and that was the assessment of the ozone hole depletion. So if you remember, that caught us all by surprise. No one was looking for it. Someone had put out a particular type of instrument, an ozone detector, at the South Pole in the 1960s during the International Polar Year, and put it away in the storeroom. And one of those scientists down there didn't have anything to do one day, 3 decades later, and he got it out and dusted it off and set it out and took another reading. It's called a Dobson interferometer. And he said, there must be something wrong here, It's not giving me the same readings. It's like completely different. And that's how we discovered the ozone hole. And then we started looking around, and holy schmoly, there does seem to be a problem here. It's a very complicated one, with a lot of potential impacts both on industry and on products which people are used. So I said, how do we tackle this? So they put together a team of people to look at all the evidence, and they came up with this assessment of, if we don't do something about this, we're actually in deep trouble. And only a year later, the Montreal Protocol was signed, which, as you know, phased out the chlorofluorocarbons, which are depleting the ozone hole, and the rest is history. The ozone hole is actually gradually decreasing now, and so a great application of a method to a problem leading to a political solution. And so people who were starting at that stage to worry about this problem of climate change said it has the same attributes, and it's going to need the same kind of machinery to back up the science. So even before the Rio Conventions, the Framework Convention on Climate Change, was signed in 92, in 1990, the Intergovernmental Panel on Climate Change was set up to do this regular assessment process in relation to climate change on an ongoing basis. That has been credited with moving that agenda forwards, where other simultaneous agendas, biodiversity and desertification, just didn't move anywhere, because they didn't have an assessment body. And so you could just end up in endless debate, he said, she said, kind of stuff, not going anywhere. And so the biodiversity community in the early part of this century ran something called the Millennium Ecosystem Assessment, where they said we need to take that kind of intellectual approach and apply it to this problem of biodiversity loss, and that was the Millennium Ecosystem Assessment. And it was also hugely influential in changing the way we think about that particular problem. And since then, we've seen an explosion of this kind of approach, and I won't be talking about all of it, but I will be talking about some instances where I've been involved, in particularly here in South Africa, showing how we've taken that methodology, you could call it a technology if you like, it's a social technology, a social scientific technology, applied it to local problems in order to solve issues which are extremely high in the social consciousness and importance for the development of the country. So, what makes an assessment, and how's it different from, we've been doing scientific studies forever. You've got a problem here, that's right, you write a contract with the CSIR, it's for, 10 million rand, in, 2 years you're going to deliver this report and, we'll deal with it. Well, that's still a viable method. But that's only for problems where there's a kind of a clear, science research structure that you need to do, and you don't have to deal with all of these trade-off issues, these value-based issues, these knock-on issues, a whole lot of different social contention. It doesn't work there. So for those kind of situations, you need this co-generation methodology. So it involves both the scientists and the stakeholders. And importantly, the scientists aren't in charge. They have a critical, indispensable role, but they're not calling the shots. The time when it was, I'm the scientist, I'll decide what's right here, you just have to go and execute it. For this kind of problem, that time is past. It simply doesn't work. So you actually ask the stakeholders, very broadly defined, anyone who can actually put a spanner in the works is a stakeholder. That's a simple definition. You engage that entire community, whether you like them or not, whether they're your mates, whether they're uncomfortable bedfellows, it doesn't matter. You engage with those and say, what is concerning you? What questions do you think are important? And you use that, you go through a couple of iterations to make sure you all understand it, and then you use that to guide what subjects you study. The second important attribute is it's iterative. You don't do a study, chuck it over the wall, as one of my former colleagues at CSIR said, and hope that you hit a passing problem. You don't do that, okay? You work iteratively through multiple drafts over an extended period of time, usually about 3 years, so people see this evolving as going on and are reacting to it and modifying it as you go along. So that iterative structure, which has incredibly wide review. We are quite used to scientific peer review. It means you send it to 2 people and you get their comments and you submit it. When we do review here, firstly, it goes to hundreds of people, often thousands of people. We get 10,000 comments back on a single chapter. All right. Not only do those comments come back, they're totally in the public domain. So we can't say, I don't like those ones, I'm just going to drop those. They're all there in a big public database along with our answers. It's a pain. You've got to respond to all of these things. So-and-so said this, you're wrong because of that, okay? Someone says that, thank you very much, we understand what you're saying, we've done the following, to incorporate it. Very onerous process, but it's what gets you the credibility. It's what gets you the buy-in. And then, unlike many studies in the past where you'd say, okay, here's a problem. It's got a dimension of hydrology, it's got a dimension of air pollution, and it's got a dimension of impact on the vegetation. So we're going to appoint, Joe here, he's a hydrologist, Mary here, she's an air pollution specialist, and Zanili is going to do the impacts on plants. And they go away and maybe appoint one other person to assist them, and they write it up and give it in to you. We don't take that approach in assessment. We use very, very large writing teams. So they're typically 10 authors or more. Because the approach isn't that you're trying to use an objective scientist who has no irons in the fire. We understand that in these socially contentious issues, we don't want our experts to park their opinion at the door. Okay, we can't do that. It's not physically possible to do that. So we bring everyone's opinion into the tent. Okay, and your result isn't kind of a single, usually consensus. This is the range of well-supported opinion. Okay, this is the tolerable range, of understanding out there. And that approach is much more robust against bias and perceptions of bias than just saying, I'm a scientist, I would never be biased. Okay, we have our bias just as like anyone else does. Okay, and importantly, explaining to my science colleagues, you're not just doing a scientific review. We were all trained how to write a scientific review. A scientific review is work by scientists for scientists. An assessment is work commissioned by society, executed by society, for consumption by society. It's actually a completely different animal. Okay. And it's also not a research project. We don't go and find out new data. You don't have the time for that. You assess what is known, what's on the table as we speak, okay? What do we know, what don't we know, how confident are we of it? So the important thing is assessments are slow, take several years, 3 to 5 years. They're expensive, 10 million rand, okay? And they're complicated because you've got an author team of 150. And stakeholders of 600, and there's all this societal noise going on. Don't do it unless you have to, okay? If you're sitting down here in an area of just one domain, or it's simple, there's no complexity, and this is the sort of scientific axis here, and that's the social axis there, uncontroversial, okay, versus super controversial, that's where you do assessments, okay, where it's technically difficult, and highly contended. That's where you put your assessments. Down here, business as usual, the technical report, the contract report, whatever approach that you would use normally. So let me go over a couple that I've been involved in. So when we did the Millennium Ecosystem Assessment, this was this global assessment of the impacts on biodiversity of a changing world. We did something really very innovative in that. For the first time, we asked about how do you translate information done globally down to where the rubber hits the road, locally, and back up again. Okay, that hadn't been done before. IPCC, for instance, runs these big global models. You try and find yourself in there, the blob is as big as your country. That doesn't help you with decisions you need to make, okay? So there's a whole process of how do you get that down to the local scale. And in reverse, how do we take the detailed knowledge which experts have, scientific experts, indigenous knowledge experts, local farmers, and bring that up to the global scale? This is non-trivial. It's a whole area of scaling theory. And we first tackled that in the Southern African Millennium Assessment sub-regionals, and it's still a benchmark in that area, where we studied at 3 different scales, okay, in addition to the global scale, and showed how you could move information up and down while maintaining its coherency. The other interesting one was the elephant assessment. So some of you may remember, about a decade ago, the newspapers were just full of stuff around elephant culling. It was the hot issue of the time. And the society was split. There were people who said, you've got to cull elephants, you've got to manage them, there's just too many of them. The other bunch said, not my dead body. You know, these are sentient beasts. It's like murdering your grandmother. And there was this complete impasse. I had just come out of the Millennium assessment, and I spoke to the then Minister for Environment. I said, I think I can help you out of this corner. What you need to do is run a scientific assessment, okay? Because that process leads you to a convergent solution instead of this very polarized solution. And so that's what we did. Interesting innovations here is we reached deep into the humanities. So this wasn't just narrow sense biologists and that kind of folk doing this. We brought in economists asking, what's the value of an elephant? Interestingly, an elephant alive is worth several times what an elephant dead is. That really changes the way you think about the problem. We brought in experts on law. What does the law say about how you can treat an elephant? Okay. Interesting consequence of that is we all thought that South African law had changed such that if you had animals on your farm, you owned them. You could do with them. Not true. South African law hasn't changed. They are still what's called res nullius. They don't belong to anybody. Okay, interesting. Still hasn't changed, by the way. And ethics, because fundamentally this is an ethical question. So we got ethicists. Where do you find ethicists? You go into theology departments. That's what they're trained to do. And they really shone a spotlight on this problem. Previously, the animal rights people had the moral high ground, okay, and everyone else was just, a dirty, money-grubbing, would-be hunter, okay. They really shone a light on that and said, no, there actually isn't moral high ground here. There is the ethics of consequence, and there's the ethics of intent. And those two are working in opposite directions here, and it really helped. So the outcome of this was the publication of the elephant norms and standards. Who's heard about a high decibel argument about elephants in the last 8 years? It went away. Okay, successful application of the approach to the problem. Shale gas development, which you'll hear plenty about in the next few minutes. The interesting thing here is that South Africa, the CSIR, 30 years ago, more or less, developed the whole impact assessment process for South Africa, the EIA. We wrote the textbook. We did the first ones. We were the big leaders in that field. Subsequently became policy, and I have to say, has become a tick box routine, deeply unsatisfying to almost everyone involved. On this shale gas issue, we needed to get out of that rut. We needed to do something which wasn't superficial, okay, which needed to look into the issues in depth and to take the helicopter view, not the detailed view. Should we be doing this? Where should we be doing it? How much should we be doing? What should be, what has to go along with it? Those kind of questions, okay. And so what we ran was the shale gas assessment, which is, I think, without any contradiction, was the biggest environmental assessment ever done in South Africa, 130 authors, okay, 17 topics, very, very detailed, very, very thorough. A spin on this is that you can't put together teams of that size and pay them. So it all has to be done voluntarily. And that has some real advantages, because what it prevents is people saying, well, of course, you would have said that, as happens with EIAs all the time. Of course you would have said that. The company employed you to do it. You would say that, okay? But none of these people are getting paid for it. So there's no argument that they are biased because they've been, bought off to do the job. All right, so where are these things going? Here's some things which we need to watch out for in the next few years, positive and negative. The first one is assessment fatigue. So when we started doing these things 20 years ago, it occupied maybe 5% of the time of 10% of the scientists. Now it's become such an important process that people like me, I'm spending 50% of my time on assessments. I never set out to do that. I actually want to do research, and I want to teach students, all sorts of things. So there's this problem of how do you actually make the space to do this critically, socially important, task. The second issue is, now that they've become a feature of the science policy interface, some of those clever lawyerly sorts who occupy the other half of this are going to say, how can we manipulate this process? How can we get into this very open process and actually manipulate it to our advantage? So I think it's quite a robust process, but we have to, as scientists, we're not trained in political economy. We don't always understand when we're being manipulated or outmaneuvered. We actually have to think about, how do you set up these, how do you govern these projects in particular in such a way that they don't end up being captured? And then the really interesting one, which is evolving all around the world now, is this idea of multiple epistemologies. So epistemology just means a kind of a worldview, a way you look at the world. And we share a worldview, most of us. It's a kind of a science-based, mathematical, evidence-driven kind of worldview. But we're increasingly having to incorporate non-science, and that's not nonsense, it's non-science worldviews, because we are 1% of the world, okay? 99% of the world uses other evidence bases to come to its decisions, okay? And for instance, we have to incorporate indigenous knowledge. There's deep well springs of knowledge, in the indigenous. How do you incorporate that with this other information? We also have to incorporate lay expertise, local knowledge, which is not necessarily indigenous, okay? How do you incorporate that into the process? And how do you incorporate things like faith-based knowledge, okay? People believe things because, that's how they believe the world is organized. Those are very powerful forces. And art knowledge, that's a way of seeing the world, which can be very powerful on certain of these issues. The key issue in the shale gas, in my opinion, is something called sense of place, okay? Don't give me all this stuff about parts per million and, micrograms per million. I don't want to see a drilling rig in this place which is, semi-sacred to me. That is an aesthetic judgment. Who does aesthetic judgments? Artists do, not scientists. Okay, so we have to broaden the scope of who we regard as an expert. So, finally, where does the CSIR fit into all of this? The first point is that all the stuff I've discussed here was done at the CSIR. Through my career here, that's a lot of what I did. And all recognition to the CSIR for giving me the space to do that. It's not science in the sort of very narrow traditional sense, but I think has been enormously impactful. And the big picture here is that the CSIR, I think, is one of the most incredible developmental interventions in the history of this country. In 1946, when they founded it, that changed everything. It put us onto a different path, wonderful. But the environment which the CSIR operates in evolves, okay? Back then, they were the only game in town. Now there's all kinds of other institutions, there's different questions, there's different pressures and whatnot. What's remained constant is that to support a place like the CSIR, it has to add more value to society than it consumes from society. That's a given. Otherwise, what are we doing? The point is, how do you add value to society? There's two ways. You can add value to society by doing stuff, by creating an industry, by inventing things, by becoming more efficient, by developing new exports, and that's great. You can also add value to society by minimizing losses. Okay, profit is the sum of costs and income. So you can work on the income side, you can also work on the cost side. And if you're saving society by doing this kind of work, making serious mistakes, you are adding as much value to society as if you were inventing something which creates some new value somewhere else. Those things are equal, and we need to understand that they have different parameters around them. And I think that the CSIR is incredibly well placed to do this kind of work because it has enormous credibility. It has cross-disciplinarity, it has enormous credibility amongst all sectors of society. Long may that survive, okay? That we are not seen as captured, that we are seen as honest brokers. We can't do all of this work because it's too multidisciplinary, okay? But we can be the people who put it together and add that value. And I would challenge my CSIR colleagues, raise your eyes a little bit, okay? Don't do what scientists love to do, which is to burrow down into more and more detail on less and less. Try to think about how can this organization, this great organization, add to the development of the country by bringing its unique powers, which you couldn't do out of a university department or out of a consultancy or something like that, and actually add the value which you can add by doing processes such as this. That's me.